Hey guys, what's up everybody? Welcome or welcome back to the Apex Academy of Mathematics tutorial channel. We are learning the language of the universe begins here. My name is Akin, otherwise known as Apex Elenio, your math guru and trainer to becoming a math genius. If this is your first time here on my channel, please of course hit the like button below, smash that subscription button, and of course turn on your post notification bell for future tutorial videos like this one and so much more. Alright guys, and this is of course an exciting video today, a video regarding an approximation concept which we refer to as standard form or scientific notation, one of the very fundamental principles that give many students across the world many issues. So in today's video we are hoping that we can of course clear up a lot of the misconceptions and give everyone some clarity on this concept today. This might be a little bit lengthy video, so of course please watch this video in your free time to its entirety to get full value from this video. All right, so let's jump into the video by explaining a few concepts and principles regarding this concept here. All right, so let's get into it. So as you would have seen at the top here, that approximation in standard form is or otherwise called scientific notation. All right, so any one of these terms that you do see in the future, the concept which I'm going to be teaching you here is as it relates to these two here. All right, so the first thing we want to do is, how do we know if a number is in standard form, or what does it look like? And so it says here that a number is said to be in scientific notation or standard form. I forgot the word form here. Standard form if it's written as a multiplied by 10, and this here means to the power of n, or to a index n, not 10 but n. All right, so it is a times 10 to the power of n. Usually when you look on an exam paper, it will be written as a times 10 to the power of n. That's how it's mostly written, but due to my software I have to use this indication here, to the power of n. All right, so please make note of that. So this is how you know if a number is in standard form. All right, so what is a, what is 10, what is n, and how do we find these numbers? All right, now it says here that where a is a real number, and of course do check my channel for the different types of numbers. I will be explaining to you concepts of real numbers, whole numbers, integers, rationals, irrational numbers, and so forth. So do look for that video in my playlist below. So a is a real number, means it's a number that could either be a decimal or a whole number. All right, 10 is a constant base, meaning that it will never be times 9, times 8, times 7, times 15. It's always going to be a constant base of times 10. And of course n is an integer. Do of course check the video out for what an integer is. I will leave a link in the description below for you to check out integers and principles involving calculations of integers. All right, good. So here's an example of how you know a number is written in standard form. It says here, example, 2 multiplied by 10 to the power of n. Here this 2 represents my a, 10 is my constant base, and 3 here is my n, my integer. And here's an example where a could be a decimal, where it's 4.12 times 10 to, and here you can see n may not necessarily be a positive, but it can also be a negative number. All right, wonderful. So it says here that a must be a number that is greater than or equal to 1. But it can also be less than 10. So whatever number I'm going to write here, it cannot surpass 9.99999, and it cannot go below 1. So you cannot have a number for a being 0.9. It has to be 1, or it has to be a number between 1 and 10. highest number being 9.99. All right, wonderful. If you are understanding the concept so far and you're comfortable, please don't forget to hit like on the video if you're enjoying the concept so far and you're understanding. All right, let's continue. I have written here for you a domain or a interval. This most likely will be written as a is greater than or equal to 1, less than or equal to 10. But once again, because of my software, I have to be using this sort of concept here, but most likely you'll be seeing it written like this in textbooks and papers. This is called a domain for the range of numbers for which a can be. All right, and here base 10 will always be base 10 and not a different number, not times 9, not times 8, not times 5, always will be times 10. N is an integer. Please, of course, as I mentioned before, check the video out for what an integer is. But for reiteration, an integer is a negative or a positive whole number. So n can be a negative or a positive number, no matter how large it may be. All right, wonderful. Let's go on to the next page to see how much more we can learn from this concept here. All right, good. So it says here the rules for getting a number to become or to be written in standard form. And here it says writing a number in standard form requires 2 steps. It requires 2 very simple steps. Step 1, you are required first to move the decimal point, if needed, behind the first non-zero digit. You're to move it behind the first non-zero digit that you recognized in the number from the left to the right. So when you look at a number here, say for example 2766128, the first non-zero digit from left to right is actually 2. So wherever the point is in the number, whether it may be here or it may be at the end or it may be out here, you need to move that point right behind the 2 right here. That's for example if this was the number. Yes, so you must identify your first non-zero digit, hence moving the point in that direction, whether it be left or right. Okay, so that's the first thing that you want to do. Now the direction we move the point is dependent on where our first non-zero digit is. Sometimes we may have a number like, say for example 0.0014. our first non-zero digit is the 1, or we may have a number like 216.158. our first non-zero digit is 2. So the direction we move our point is dependent on where our first non-zero digit is. All right, fantastic. I hope you are enjoying the video so far and you're understanding the concept. Now I've placed here in pink for you that you are to note well that the direction we move determine the integer value, meaning that the value of n is determined by the direction we move. So signs play an important role, as I will be explaining to you how you know if n is negative or positive and what value n will be in step 2 here. So please make note that do not forget the direction you're moving. That with these are the steps, or this is the step that will help you to determine the value of a. All right, let's jump to step 2. So excited to get into the examples, but let's first take care of all the prerequisite skills we need to make sure that we understand the concept going forward. Now it says here, step 2, the value of n is obtained by the amount of movements that was made. The value of n is obtained by the amount of movements that was made. So if, say for example, you move 3 places to your left, n may be a positive 3 or a negative 3, or if you move 4 places to your right, n may be a positive or a negative number, but it will often likely be the number 4 depending on if you move 4 places or 3 places to your left or right. All right, wonderful. Now if we move to the left, if we say that we are going to move in that direction here, this direction, Yes, if you're going to move in that direction. If we move to the left, n is going to be a positive integer. So if we move 4 places to our left, n will be positive 4. But if we move to the right, n is negative. So if we move this direction instead, say for example 5 steps to the right, n is going to be not only 5, but it's going to be negative 5. All right, so let's jump into the example to make sense of this. Please note that there are instances where you may be getting a question that doesn't even require you to move the point. So I do have an example for you. Let's make sense of all these notes that we have been through so far. All right, we're almost done, guys. We're at 10 minutes, so let's get into the examples here. So it says here, rewrite the following numbers. Well, this should be in. So rewrite the following numbers in standard form or scientific notation. And so for example number 1, we have the number here. Let me change ink. We got here black. Good. All right, so we have the number here for you. 0.00004356. And so our first non-zero digit here is actually let me see here. Our first non-zero digit here is actually 4 right here. That's the first non-zero digit. So we need to move our point between the 4 and the 3. So we need to move our point. Okay, so we need to move our point 1, 2, 3, 4 places right between the 4 and the 3, or better yet, behind the 4. So moving our point behind the 4, it shows here that we made 1, 2, 3, 4 steps to our right. So 4 steps to our right. Let's make a note of that. 4 steps to our right. So the number will now become after the movement is 4.356. That's the value of A. Now let us confirm. Is this number greater than 1? Yes. Is this number less than 10? Yes. So we have satisfied the criteria of A being a real number. Now we mentioned that it's always going to be times 10. So we have our times 10 there. Now here's the tricky part. How many places did we move? We move 4 places to our right. According to the rules, if we move 4 places to our right, n will be 4, but specifically n will be a negative 4 because we move to the right direction. All right, so our final answer here is 4.356 times 10 negative 4. All right, so let me just write that a bit clearer for you. This is equal here to 4.356 times 10 to the negative 4. All right, hope you guys got that example. Let's look at example number 2 for a little bit more clarity. Now our first non-zero digit here is actually this 4 again, but this time it is to our far left. All right, it is to our far left, so we need to move our point in this direction instead. And since 4 is right here, we need to put the point between the 4 and the 1, or better yet, behind the 4. All right, so once we move our point there, we know that we moved 2 places to our left. 2 places to our left. So we know that the new number now will be 4.126257. That's quite a long number. We could do some approximation to that, but not in this video. We're going to be doing future videos where we are going to be putting numbers in standard form, rounding them down at the same time to significant figures or decimal places. So for now, we're going to keep A to be this very long number, 4.126257. all right, now we know it's always going to be times 10. But what is n? N, now in this case we move 2 places. All right, but is it a negative 2 or a positive 2? The rules accordingly states that if we move to our left, n is going to be a positive integer, and in this case it's going to be a positive 2. all right, so hopefully you guys are understanding the concept so far. All right, great. Let's move on to example number 3. Making some errors here. All right, so example number 3 here is the number 93,678,512. Now there isn't a point that's visible in this number, but every number has a point. So if it's a whole number, the point is usually at the very end, right out here at the very end. So we're going to have to move this point, because numbers that come after the point, if it's not visible, are zeros, a bunch of zeros. So the point is at the very end right here. All right, that's understood. So we're going to be moving the point to our left. So it's 1, 2, 3, 4, 5, 6, 7. 7 places. Since 9 is our first non-zero digit, we're going to have to put the point right between the 9 and the 3 right here, or behind the 9. So our new number, or our new A, is now 9.3678512, and of course that will be times 10. All right, now what is n? Now we move to our left. So left will indicate that our n is going to be a positive integer, so we don't need a sign here. All right, so we moved 1, 2, 3, 4, 5, 6, 7 places to our left. So our answer, our final answer, is actually 9.3678512 times 10 to the negative 7. All right, I hope you guys are understanding the concept so far. If you are, please hit like on the button, and if you have not subscribed, please do so right now. Please, I am begging you. Okay, all right, final example, guys. Final example. We are going to look at 6.1532. all right, now this number we are asked to place in standard form. Now this number is a trick question, or this question is a trick question. All right, because the value that we're looking at here is already greater than 1 and already is less than 10. So there is no need to do any form of movement. Any movement will cause us to be greater than 10 or even less than 10, moving to the left or right. So this number will still remain as being 6.1532 times 10 if you want to write it in standard form appearance. But since we did not move, then of course n is going to be 0. All right, if you check out my indices law, or laws of indices or laws of exponents part 1 and part 2, you will recognize that we discussed the 0 property, where 10 to the power of 0 is actually equal to 1. So 1 multiplied by this number will give you the same number, and it goes for all these other examples here. All right, guys, so that brings us to the end of our standard form and scientific notation tutorial video, and I do hope that you enjoy this one. My name is Akin, otherwise known as Apex Elenio, and of course please stay tuned to this channel for future tutorials by turning on your subscription button below and smashing that notification bell. Do take care, and I'll see you next time in another video for more content in math. Please stay safe. Take care.